Greetings, future elementary educators. In this screencast, we're going to take a look at surface area. And when we say surface area, we mean the area of the net that makes the solid. You may also think of it as the sum of all the areas of all the faces of the solid. That's also fine. Either way is fine to think about it. So you're either thinking about the area of the net that makes the solid or the sum of the areas of all faces of the solid. Either way is fine to think about. So the simplest example for us to think about would be the rectangular prism. Let's make this a 3 and a 4 and a 5, and of course there are 6 faces to the rectangular prism. If we decompose the rectangular prism into its net, you've got rectangles here, and you've got rectangles here. Well, how big are those rectangles? Well, the ones that kind of flop off to the side are the bases over here. And in this picture, they are 3 by 5. Oh, that's false. They are 3 by 5, where the 3 runs along the bottom and along the top, so it'll flop down. And the 5 kind of flops out this way. So the 5 is here, which means it's also here. 3 by 5. Then this rectangle that's the bottom of the solid is going to be this rectangle that's here, and that is a 4 by 3. This is 3, so that's a 4 by 3. And that'll also be on this side over here. That's a 4 by 3. Which means that this rectangle is the one that's left, and this is the one that kind of flops down like so. So this is a 5 by 4, and this is also a 5 by 4. So what's the surface area? Well, 3 times 5 is 15, and it also happens on this side. And 3 times 4 is 12, and it also happens on this side. And 5 times 4 is 20, and it also happens on this side. So the surface area is 15 and 15 and 12 and 12 and 20 and 20, and that's 94? 94. Every prism can be decomposed in this way. You get a bunch of rectangles, and then you get the bases on either side, and we figure out the areas of each of the faces, add them together. So pause for a moment, and let's try this. This is a triangular prism, right? And let's suppose that, I don't know, that's 6 and that's 4 and this is 5 and this is 5, because that's fair. And then this is 10. Pause for a moment, stop the video, make sure that you can find the surface area of the prism. Okay, so there's a base that's sitting on the ground, and that's a 6 by 10. Okay, that's a 6 by 10. And then there's this rectangle here, which is going to show up over here, and that rectangle is a 10 by 5. And it's also up here. So then you got this triangle here, and it's on the other side also. And that triangle has 5s here, but a 4 there, right? So rectangle with area 50, rectangle with area 60, rectangle with area 50. What's the area here? 1/2 base height, right? And so this will also have an area of 12. And so the surface area is 50 plus 60 plus 50 plus 12 plus 12. And that's 100, 160, 184. We can do this with any prism. We find the net, we add all the areas of all the parts of the net together, and we've got it. There are a couple of things to consider because not everything is a prism. In fact, some things are very not prism, right? This is the cylinder, and you've got some radius on the base, and you've got some height, and we want to find the surface area. Well, what surface area? It's the area of the net that makes this solid. What makes this solid? Well, there's a circle that represents the top, and there's a circle that represents the bottom. And then when you unfold this part, you get a rectangle. Height is h. What's the length of the rectangle? Well, the length of the rectangle comes from unrolling the cylinder. This is the circumference of the circle. That's 2 pi r. So the surface area is the area of the rectangle, length times width, plus area of a circle, area of a circle. The formula comes from somewhere. It did not fall from the sky. The formula comes from somewhere. Not everything is a prism. Some things are cones, and the cone has a circle on the one end of it, and it's got this height, and it's got this slant over here. And how do we find the surface area of a cone? Well, surface area of a cone, the circle part is pretty straightforward, right? That's going to be pi r squared. But the rest of it is not easy because the rest of it is a sector of a circle. And it turns out, for reasons that don't really matter to our course, that that's pi r times the slant height, pi r times L. So the surface area of a cone is pi r squared plus pi r L. It's the circle's equivalent of pyramids, which we can break down in the usual way. There's only one other thing for us to think about, and that's the roundest of round three-dimensional shapes, the sphere. We can't even begin to think about how this works in our course. For those of us who have studied calculus, we take the derivative of the volume of a sphere to come up with surface area because we're basically finding tangent planes at every point, so to speak. It almost makes sense if we think about it. So the surface area of a sphere is 4 pi r squared. And that's just a formula that we just know because there isn't any better way for us to go after it with the level of our course. So we trust that it works. Okay, my 10 minutes are about up, and so you are on your way to other things. Thanks for sticking around this long.